So guys, let's start. We are somewhere here. The Docker bridges and over. So guys, Docker network. Say bridge network, host network, other one is not. The other special network is there, overlay network. Overlay wheels. Okay. So the Docker swarm, right? So Docker swarm uses overlay network, guys, right? So guys, last class we have discussed about bridge network. What is bridge network? Right? Today we are going to discuss what is host network and null network. Right? There are two things. Say host networking is like this, guys. So this is the Docker host. This is the Docker container. This is the Docker host network card, guys. Okay. So it's connected with the network card. So we all are outside. Say Docker host network means, guys, right? Say host means host network means this container uses this network card IP address. This network card IP address. So it has two IP address, the public IP and the private IP, isn't it? So you see here. So it uses two network card, guys. One is public IP address, other one is private IP address. So the container uses the private IP address. The Docker bridge is different thing, guys. The bridge comes here. Last class we have learned the bridge network, guys, isn't it? So it uses this the bridge IP address. Bridge, so the users means bridge creates some IP address, guys. Right? It uses one of the IP address. On the other hand, host means the container uses the network card IP address, network card private IP address, not public IP address. Right? So guys, this communication is bit speed compared with bridge network. The bridge network, guys, we go to first we go to the bridge. First we go to the bridge, right? Then go to the container. Here we directly access the container. That's what the host network is bit fast than bridge network, right? Right. So let's see how to configure host network. So this is our Docker host. Say if you type Docker images, you can see all the images, guys. If you want to download images, guys, say Docker full, then mention the image name. Say it's a Red Hat or MySQL or Debian, whatever it is. Say MySQL or something. I can download MySQL images. Now see, say download a new image, right? Download the new image, right? Say Docker images. You can see the MySQL image has been downloaded. It's a latest version. You can see the size of the image, right? So it's download from hub.docker.com site. Okay. So these are the free images, guys, public images. Anyone can access, right? Public images. So these images come from hub.docker.com, this site. Here you create your own account and post your images, right? Those are the private images, right? Okay, let's see what is host network, right? See here, let's run a command, right? That's all. So let me run a command, guys. Say, look here, Docker run interactive IT name, say container 1 or something, C1. So network host, just mention the host, guys, okay? Network host, and the image name, say let me go with Ubuntu, right? Ubuntu image, Ubuntu, right? Here or network host network, guys, right? Network host network. It's not a bridge network, okay? It's a bridge, just mention the bridge. It's a host network, right? Right, yes, enter. Unable to find the image. So unable to find the image, network latest Docker. Docker response from daemon full access does not exist or request login. So they're saying the Ubuntu image is not there. Let me download the Ubuntu image again. Right? Say Docker full. Yes, full like this, right? Ubuntu. It's downloaded. So it has download the image already. Let's see, Docker PS. I think the container is already there. The name already existing. So we have created the container name as C1. The C1 already exists. C1 is there. Let me go for the different name. So C1 name already exists. So what you can do is delete this container, the Docker RM C1. Now type like this and see. It's deleted. Okay. Let me delete other containers as well. So I have deleted a couple of containers. Now let me run the command or use the different name. Or use the different name. Or delete the previous name container and create the new unit. Right? Say like, let me go with C1. So right, okay. Give me a second, guys. Give me a second. Give me a second, guys. Give me a So right, so the issue is the command. You guys should use dash network. Right? Right? Use dash network. Right? This is the right command. Right. Right. Say once I apply the command, guys. Once I apply the command, you see, I am somewhere here. I am inside the container. I am inside the container. You see here. Say, let me type ifconfig. Ifconfig not found. Okay. First of all, update the container, right? Say, just type ifconfig. You see the container IP address. This is the container IP address, right? The container IP address. You see the container IP and the host IP both are same. Say you see here. This is the container IP address. This is the host private IP address. The compare the IPs, guys. Compare the IP 172.31 8.100 172.31 8.100. So okay, the same IP address. Same IP address. If you want to exit from the container, what is the command? Say, what is the command to exit from the container? Control P, Control Q. Now, I am in the Docker host. I am in the Docker host, guys. Okay. Just type Docker host, just type IF country. It's a Docker host IP address, same IP address, 172.31.800. The same IP address assigned to the container as well. This is the container IP, guys. This is the container IP address, same IP assigned to container as well. This is the container's private IP address. Right? It's a Docker host IP address. So it has two IP addresses, private IP and the public IP. This is the Docker host private IP address. Private IP address. Say, look here. Docker PS. You can see the container is running. Is the container is running. If you want to access the container, Docker attach C1. You can go inside the container. Now we are inside the container. The host network means the container IP address and your Docker host IP both are same. Host network. Okay. So let's install Apache and access this Apache from outside. fpd install Apache. Service. So the Apache HTTP server could not build address 80 already in use address 80. Okay. Right. The thing is the say uses the same port, right? Then we have to define a same port for this one, right? So the already in use. Okay. Someone already used this particular port. Say Docker PS. Sorry. We are in the container, no? Okay. Starting Apache to web server, socket not built Apache. Could not build at the system. No listing socket shutdown. Okay. Say, let me install Nginx. Let me remove this one. You can try to install it. Let me update the container. Okay. So guys, give me a second. Control P, Control Q, just back to the Docker host. Let's get the command. I think the port not mapped. Let me change the name this time. C1. Okay. Let me stop other containers. So Let me delete other containers, right? Quickly.
So have you enabled port 80 for the Docker host?
Let me check. Yes. Here the thing is Apache is running here. That's the reason. Now I stop the Apache here, right? Say a Docker PS a Docker dash C3. It now should work, right? Okay. Yeah, now it's working, right? Because the here I enable port 80 in the host, right? Now see guys, when you access this one, the traffic goes to the contain, right? Right? Now see guys, say let's get the public IP address. Now see, now I can able to access the Apache test page, which is running on somewhere here in the contain. Right? Contain. Right. Right. This is the Docker host. Right. This is known as host network. Right. Host network. Right. This issue is both the contain and the Docker host port 80 is enabled. That's it. That's what they're saying. Address already in use, right? Some other host uses port 80. That is the reason it won't allow container to use port 80. Right? So it could not bind because someone is using, right? So here I stop the Apache. I stop the Apache in the Docker host. Then I disable port 80 here. Then port 80 allocates to the container, right? Then I can able to access now, right? Right. So this is the host networking, right? Okay. Right. There's a question. So in this case, if we create one more container within the same Docker host, will that container also get the same address? Yes. If you run another container, guys, right? It's also getting the same IP address, right? Say, wait, control P, control Q. I am somewhere here. Say if I run these things, right? So let's see, this is C4. It also get the same IP address, C4, right? Say it's also get the same IP address, right? Right. So in this scenario, we go for only one machine, right? The host. So if we go for another machine, it's also assigned the same IP address, right? But
So in that case, we can't assign the same port for the two containers, right?
yes, correct. We can assign the same port. Then we have to go for the different port. Say if you go Apache here, say you can run Apache 80, then you can go for this Apache in a different port, say 81 or something, right?
Okay.
Go for the different port, huh? Right. So that's the thing. Next one is the null networking, guys. Okay. The null part. This one guys we rarely use. That means the container is isolated. So if you go for a null networking, guys, this is the Docker host. So this is the container. If you go for null, the container is isolated. It won't expose to outside, right? It won't expose to outside. It's isolated container. It won't communicate with other host, right? Null network, right? So this one is very simple, guys. Just go to the Docker host. So, but here there's no port here because, right? Say network is equal to null network. That means null. Just say null. Right. Save. Let's go for a different name here. Say C4 or something. None, I think. Because he's saying the C4 already there, okay? It's conflicting C4 container already there. I can go for C4. Let's go for a C5. Now I have created. This time network is none, guys. Right? The container is isolated. So this one is okay. The container is isolated, guys. It won't communicate with other containers or right? None. That's null networking, right? Null network. Right? So just say a network or none, right? That's all, right? So this also rarely using scenario, right? Non-network, right? Say control P, control Q, right? Right. Say Docker PS, you can see the the container, the running containers. If you want to see all the containers, Docker ps minus a, you can see all the containers. That means dead containers as well. Right? XC, that means dead containers. So, dead containers. Right. All right. So that so we have so is the host part, host networking, guys, because this is the command, right? Docker run minus d. Okay? You can use minus d as well. Let's see what is minus d, right? Minus d option. Now see here. It's a daemon mode. Minus d means daemon mode. Okay? Say rather using this one, rather using interactive daemon mode, minus d. Say let's use the different name C6 network. Say host or something, whatever network name. This time I would like to go for minus d. Right? Just observe here. Just observe here. Right? Again back to Docker host. So if you use minus IT, you go to the container prompt. Say if I use if I use minus IT, guys, so we go to the container prompt, say interactive. Say let's use the different name, right? This time observe, we directly go to the container prompt. Say if you use minus D option, it's a daemon mode. We again back to the Docker host prompt, right? That is a different using minus D and minus IT interactive. Right? Docker PS, you can see the containers. You can see the C. Okay. Right. 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 Say minus D option. Right. So other one is there overlay network. We'll see what is overlay network bit later when we start to use swarm, right? Swarm concept, right? Null network we rarely use. The practical cases means this isolated container is isolated. So we rarely use this one. So we commonly use bridge and the host network, right? Bridge and the host networking. So null we never use actually, right? So I'm not quite sure the test cases for this one, null networking. null. So I'm not quite sure. Anyway, I'll check this null thing. Okay, null test cases, right? Right. Right. Next one, guys. Let's see the storage. Right. Next one, we move to Docker storage. Right. How we are going to store the data. Now, see, guys. Say if we run like this. Say, let me run the container like this. Say, let me put a C8 or something, right? Save one. Enter. I just got to the content, right? So here I just ls. I try to save. I try to create a file. Just go to root. Try to create a file. Say touch. File one or something, you can see the file one. File one is running on this container. It's running on this container. The file one. So if I type exit, okay, the container will die. Or if I stop the container, container stops. So if I say exit, I exit from the container, guys. Exit from the container. What is the container name? C8. You see here, Docker PS minus A. The C8 is exited. That means the container is dead. In this case, the file also deleted, guys. So I have created a file known as file1. This also get deleted because the container is exited. If you stop the container and start the container, file is there. If you exit from the container, if the container is dead, then file won't be there. Right? To overcome this situation, right? Amazon come with a concept known as volume concept. Right? Let's see how volume works. Right? First of all, let me create a volume. Right? Say a Docker volume. Say, let's see, Docker volume, volume 1 or something. Vol1, right? Wait, Docker volume. Wait, Docker. Now, guys, I have created the volume. Okay? Volume known as vol1. Right? Now, just run the command like this. Or you just inspect the volume. Say Docker inspect sorry, Docker volume inspect vol1. Okay, inspect the volume. Now see Docker host, guys. Docker host, I have created volume vol1. Okay. If we inspect, you can see the volume location. This is the volume location, guys. This is the volume name vol1. This is the volume location var lib docker volumes blah blah things. Right now, see cd var lib docker volumes. Enter. You can see the volume cd vol1 there. You can see the data folder there. You can see the data. Say something like this. Say something like this. Look here. Now, in this Docker host, I just created a folder known as volume folder. Right, a storage. This is the storage, vol storage. Right. So this one, I am going to map with the container folder, right? The container folder, right? Say in the container, or let me put var storage or something. Var storage. So this folder, guys, I'm going to map var storage, right? There are two different mapping. There are two different mapping. Volume, guys. Okay. Two types of mappings. One is, say we call say we use a -v to map. Other one bind map. Other one bind map. Okay. First we see -v map, right? This one, right? Now see. Now look here. Let me run like this. A Docker run -it interactive and give the name of the Docker, say C5 or something. Okay, C6. I think C5 already exists. C6. Say -v. Say the vol1. I have created a volume in my Docker host named as vol1. Just say vol1, right? That one is mapped with the container storage. Say var storage. Say var store or some var store. You can use any name, guys. Okay. Any name, say storage, ABC, XYZ, any name. Okay. This one is inside the container, guys. Var store. Var store is inside the container. Inside the container. Volume is inside the Docker host. Our computer, right? Our computer. Right. Say, let me use the image as Ubuntu or something, whatever. Say, make sure the name 6 won't be there, right? Right, enter, guys. I think the name 6 already in use, right? Use the different name now. Say, 8, 7 is there, 9, right? 8 also there. Now it's done, guys. Right? Now, say whatever I store here, files, the file comes here as well, Docker host as well. Suppose if someone delete this container, so we can save the data. The data is saved. Previously, guys, someone exit or delete the container, data also deleted. Right? In this setup, if someone delete this container, we can save the data, isn't it? Now see, guys. I'm inside the container. Let's go to the var storage, var store or something. So folder. Here, let me create a file. Let's say touch something. Touch file one. Right. So the file one goes to vol1. Okay. Say what is vol1? This is vol1, guys. Vol1, right? This is the Docker host storage, right? Say copy the path here. Right? First of all, let me exit from the container. Say Control P, Control Q. I'm in the Docker host. CD. Just go to this path. Yes, this path. Valib Docker volume. This one. Enter here. ls and C. You can see the file one is there. File one is there. File one. The file one is in my Docker host, in my computer, guys. Okay, it's in my computer. File one. Right. Say again, a Docker attach. Just say a Docker attach. Go to this one, the container C1, right? Here, here the file one is there. You can see the file one is there, right? Give me 1 second, guys. Give me 1 second. Right? Right? Say Vasto, you can see the file, right? Let me create another file. Touch file 2. ls, you can see the file 2 here, right? Control P, Control Q, just go to the host, say ls. You can see file 2 here, right? Now see, let me delete this container. Right? What is the Docker PS? Now this is the container name, C9. This is the container name. Let me delete the container. So if you want to delete the container, first of all, stop the container and delete the container. Right? Docker stop C9. Now the container has been stopped. Right? Now see, Docker rm remove C9. It has been deleted. Okay. Say Docker PS and C. You won't see the container 9 here. It has been deleted. Say ls. You can see the data is there. Okay. We can save the data. Right. So we can save the data. The data is here. The file 1, file 2 is there. Right. Okay. The data is here. Right? There's a questions. So the command to get the volume detail within the Docker host. Within the Docker host, no. So within the Docker host, there's no commands, right, to get the volume details. But when we create the volume, we know the say here. When we create the volume, we know this volume. Okay, this one is mapped to var store. This one is in Docker container. This one is in our Docker host. Right? So, right? There's no command to view the volume details inside the container, right? Inside the container. The reason is why we can use the volume command inside the container is we are creating volume and all in the Docker host, right? We are running the volume command and all inside the Docker host here, right? If you want, you can inspect the volume here. Okay, here you can run any volume inspect command or something, right?
I just want to know how did you go to the volume in the host, Docker host? How did you get this path? Volume Docker.
Yes. Sure. Okay, so what you this one, no? Okay, this one just type like this. Docker inspect vol1. Right? If you inspect, you can see the path here inside the Docker host. The container you want to run these things. The host run like this: Docker inspect vol1. This is the mount point is there. This is the mount point.
Right. So thank you.
Okay, this is the volume, right? The inspect command. So we use inspect command. Right? Okay, right. That's your question. And okay, next one. Right? So we have learned these things. So we have learned the -v option. Okay, -v volume. First of all, we create the volume, and specify the volume -v. Right? The second one is, guys, the mount point. The bind, we use bind mean the mount point, right? Let's see how it works. Say, for example, NFS we use the bind and all, right? NFS we use the mounting and all, right? The same concept here. Right? Now see a Docker PS. Now, let's see how the bind mechanism works, right? Say Docker. Seat. Let's go for the different name. This time, use this way. First of all, let me create the mount point. Bind or something, whatever name, right? This time, guys, we are creating folder. This time, guys, we are creating folder. Previously, we have created the volume, right? So just this folder, then say storage or something, right? It's a container folder, right? Say Ubuntu, right? Make sure it's in, this should be a different name, C10 or something, right? Now see enter. Error response from invalid container name. Okay. Let's go for the, let me go for the, right, CC1 container one, yeah, put like this.
So I think that's because of the minus CC1.
Ah, yes, so the name is wrong, yes. Yeah, you are correct, yes. Okay. It should be something like the CC1 or CC2, okay? But don't use minus here, okay? It's wrong. Now it's okay, right? Now see, we have created CC1 contain. Right? Now see here, go to this folder, storage, CD, storage here. Say let's just create some files. Say touch file 3, file 4, ls, and say you can see the file 3 and file, right? Say just press control V, control Q, and let's go to the bind in the Docker host folder. Docker host folder. Control V, control Q, enter, cd, bind, ls, you can see the same file. This time we use this one. We mounted. We just created a folder in our Docker host, and this one we mounted with the container. Previously, we have created the volume, right? Say both we use minus V, yeah? Both we use minus V, right? So this folder is mounted with the container folder, var source, right? Okay. Right. So like this, we can save the data. Okay. Like this, we can save the data. If anything goes wrong in this container, guys, still we can survive. Right. Data is there. So what we can do is we create another container and connect with a particular storage. Then this container uses this data. You may ask the question, more than one container uses this storage. Yes, yes, can, right? More than one container uses the same data, right? Say this also can access this volume. So if you have another container here, it also can access this volume. This also can access this volume. More than one container can access one volume, one storage, right? That is possible. Say, right? Okay. This is the Docker storage. Docker storage. We use two methods. One is -v volume method. Other one is bind method, right? So both we use -v, right? We use -v. This one is volume, right? This one is bind mount, right? Bind mount. So if you say less, you can see the data. Data is there. Right? There are two type of storage. The other one is there. This one we rarely use. Okay, there's no use cases for this one actually. So this is known as TMPFS, like TMPFS, temporary file system. So this file system in RAM. So some sort of speediness, right? Speediness we use this one, right? TMP mounting. Okay, it's a rarely using scenario, right? That means we can mount this one to the RAM inside the RAM, right? Let me show you the demo. Now see guys. Docker run -t, say, let me go for the different name, CC2, say, just put like this. -- mount type equal to TMPFS, temporary file system. That means this file system in RAM, right? Not hard drive, temporary file system, right? Say that means if you delete the container, gone, right? If you delete the container, data gone pass. Okay, temporary file system. Right? Say just put like this. Destination is equal to say / app or something. You are the container, right? Container location, right? Something like this. Run here the RAM location, okay? Temporary file system. Destination is something like this. Just enter here. Say cd / app. Okay. Say whatever you store here, it goes to your RAM, right? It goes to your RAM. Right? It goes to temporary file system. So if you delete the container, data will go. Data will go. Okay, it's a rarely using scenario, guys. Temporary storing the data in RAM. Right? Type temporary file system. The app is in the app folder is inside your container. Whatever you save inside this container, all data goes to RAM. Right? Say suppose if you delete the container, data also will be deleted, right? Right. So that is the disadvantage, right? Right. This is also rarely using a scenario, guys, right? Right. So these are the storage. Okay, these are the Docker storage, right? So guys, we have learned this Docker networking and Docker storage, right? Right. Now see, Docker is there. Right? Now we have learned this Docker storage, the storage and the networking part. Now see how we are going to manage these containers. How we are going to manage these containers. So if you want to manage these containers, we have two mechanisms. Say we can use Swarm or we can use Kubernetes. Manage the containers, guys. We can do Swarm and Kubernetes. This one is with advanced things. First we complete the Swarm, then we go for the Kubernetes. Kubernetes. To manage the containers, that means we can create the containers, we can delete the containers, we can scale the containers, scale up, scale down, right? Right. Now see here. Look here. This is the Swarm master. These things known as worker nodes. You have many worker nodes, say 1 or 2 or 3. Okay, we go for maximum 2 worker node and 1 master node. Right? Say this is the master Docker server. So here we call this one is slave, or we call a worker node, right? Say a worker, say worker node 1. Say this one is a worker node 2. Worker node. These things are connected. These are hosts. These are host guys, not containers. These are hosts. So these things are connected, guys, like this. These things are connected. Host machine, guys. We are going to run the command here. Guys, we are going to run the command here, not here. We can't type any commands. Only master only we can type commands, guys. We have 1 master and many worker nodes. If you want, you can create another master also. Right? So backup purpose. Anything goes wrong, it will take care. Other will take care, guys. Take care of the operations. Right? So, right? Let's go for 1 master node. Master node. We are going to run the commands here, guys. Master node. Say here, guys, say if you run the command, guys, okay, you can create the containers here. Okay, you can create the containers in master node as well as slave node as well. Both are the same container. Say whatever software here, you can see the same software here as well. Right? You can go for, right? Say if you use the replica, okay? Say replica equal to 4, then Swarm will create 4 container, maybe 1 container here, 1 container here, 2 containers here. First, it will check the hardware resources, right? According to the resources, it will create the containers. It has more resources, then it will put more containers here. It has more resources, it will put more containers here. That part, Swarm will take care of this. The Swarm architecture will take care of that part. Give me a second, guys. Give me a second. Right. Swarm, right, okay. Swarm architecture will take care, right? This is, right? This is the Swarm architecture. Huh? Right. This is the Swarm architecture. Right? You can scale the container, scale down the container, scale up the container, right? Okay. Say, now see here carefully. So if someone delete this first, if someone delete this first, so what will happen to this container, guys? This container, guys, automatically move to another first, maybe this first or this first. It comes here and sit. Right? Someone delete the container. For the maintenance purpose, sometimes we delete the container, sorry, delete the host and create the host again. Right? In that case, these containers move to other host guys, other host. Right? Right. So these sort of facilities available in Docker, sorry, Swarm, right? Right. Say guys, Swarm, look here. Swarm mainly two type of services, guys. Say one is a replica service, other one is global service. Right. Swarm services, replica service, global service. We will see both services, replica service and the global service. Okay. Now see here, this is one of the first. See the wording first. First. Say this one is master node. So this one is the work or not? Work or not? Here we can create the containers, right? We can create one container. Here we can create another container. Here we can create another container. Right. Here let me go for another container. So here I have a user's replica 4. Right? Replica 1 1 1 1 4 containers. So guys, there's another concept known as load balancer. It's a load balancer. Load balance. So the load balancer points to this container, this one, right? Say for example, by default traffic goes to this container. Anything goes from this container, guys, if so this container is dead or something, traffic goes to other containers, right? The load balancer automatically point to other container. All these containers are same containers, guys. All are same containers. Say for example here the Apache is running, Apache and some softwares are running here. Apache and plus some software, say some sort of app is running. Here also the same thing. Apache plus app. Here also Apache plus app. Here also the same software. All are same containers. Right. So say by default this the traffic goes to this container. Anything goes wrong, guys, LB automatically point to other containers. Maybe this one or this one, whatever. Right? Later we will discuss the LB and all when we do the projects. Right? Now see here, this is our application is running here. Okay. Application is running. All these containers should have a ID, like say for example, this ID is ID1. ID1. This one is ID2. ID2. This one is ID3, ID4. Likewise, all these containers have separate IDs. All these containers have separate IDs, guys. ID and the name, guys. Say for example, this one is a app 1 point something, right? 0. What say 1.2 or something. Okay. Another containers are coming, guys. Another containers are coming here. So these are the database containers. So database containers. So these database containers, guys, this database container, DB container, uses this name to communicate. Say uses this name to communicate with that container. Say for example, say it uses app 1.2 and the particular container port number, say port number, say 8080. All these containers uses the name to communicate with the app container, other containers. If this app container wants to communicate with database container, then it uses its name and the port number. It's a container name and the container port number to communicate. Right? Let's see. Let's see the demo, guys. Let's see the demo. First of all, we create this architecture, guys. This is the master node. This is the worker node, guys. Worker node 1. This is the worker node 2. We can go for one or more worker nodes. Right? Say, let's see if the master is connected with the worker node, guys. So it's a master, guys. A master node. So it's a worker node. Say worker node 1 or something. This one is worker node 2. Say worker node 2. This is the master node. So guys, when you design these things, this one need more resources, guys. This worker node need more resources. Let's go for a 2 GB RAM or something. Okay, 2 GB RAM. Master node, just go for 1 GB RAM, guys. 1 GB RAM is in. Right? Right? So guys, let's create the architecture. Swarm architecture, right? Okay. Let me create 3 instances here, right? Just say launch instance. So this one is my first one is my master, other 2 are my worker node. Right? You can choose Red Hat or Ubuntu, any operating system. Say, let me go for Ubuntu, this one, right? This version. Say, this is one, sorry, this one is my master node. Just choose this. Say, guys, when you create this architecture in Amazon, guys, make sure all are in same network, guys. All are in same network. You can go for the different network as well, right? Then create routing and all, right? If demo, we go for the same network, say okay, same network, right? Say let me do.
So in Amazon, what do you mean by same network? Is it in the same region or?
Yes. Now see, same network means, say, okay, let me. Say if you choose same availability zone, so it goes to same network, right? Say this is one availability zone. This is another availability zone, ASL. Availability zone. This is another availability zone. So here we set up our network. Say, let me put like this. Say this one is 172, 31, 0/0/24. Okay. Okay. The outer part is your region. Huh? The outer part is your region. One region we have many available zone, right? Say better you choose one available ASL. There you go for your network, right? Maybe this network or whatever network as to wish, right? Say look here. Say next here the subnet. Choose the same availability zone. Say all these three servers goes to this one or this one or this one, right? Any of the subnet, right? Say let me choose this one. Okay, 2A. Okay, USC is 2A. So when I choose the worker node, if I go for this one 2B, then that would be different subnet guys. That would be different subnet. Right? Right. Say if your master server belongs to this subnet, your worker node also belongs to the same subnet. Then all these servers come to same network. Right? Here. Right? This is your ASL. This is the ASL. This one is your subnet. Right? Choose one subnet. Don't choose here and there. Right? So if you go for 2A, then go for then others also should follow this one. That means all these servers go to same network, right? Right? This subnet. Right? This availability zone, this is the subnet. Right? Right. Is it clear what's your name?
Yes, sir. Yeah.
Right, okay. Go for the same subnet. See, subnet this subnet. Okay, right. Say sorry. Say let me go for 10. Okay. You can go for up to 30, right? Let me go for 10, right? Say attack here. Say the tag name as this is the master server, right? Just put master. Just put master or something, enough, right? Right. Security group, let me open all the ports, right? If you know the swarm ports, guys, if you know the swarm ports, then only open the swarm port, right? If you don't know, make it all traffic, right? So this one is at existing heap. So I don't have any test. Say, let me choose this key, Docker key or something. Yeah, Docker key is there, right? Say launch instance. Now we launch the master server. Now we launch the master server. Okay. It's coming up, still in the pending state. It takes some time to become running state. Running state. Let me launch the slave servers. The same flavor, same image. If you want, okay, same image. You can go for different image, but there's some conflict there. Right? So this time, let me choose this one, T2 medium, guys. T2 medium, right? This, right? Say, let me choose the same subnet, guys. Same subnet. Previously, I have chosen this subnet. This one also should follow the same subnet. Then only all these nodes come under one network, right? Right. Let me update the servers also. If you want, if you add the script here, you can update the servers when the launch is completed, right? Anyway, yes, just later we update. This one should be A, right? A, right? Right. So these are our worker nodes. All traffic. Okay. So we launch only one machine. Let me launch other machine, right? Quickly. I forgot to do select the numbers, right? Here you can choose the numbers, okay? 1 or 2 or whatever numbers, right? So now we have launched 3 machines. This is our just put worker node. Worker node 1. So Amazon console just name like this. This one is our worker node 2. Worker node. Worker node 1 and worker node, right? So let me update these servers quickly, guys. Just quickly connect and update the servers. Quick. So guys, first of all, update these servers and change the name, right? So okay, you see the name is like this. Say if you type host name, Say if you type host name is something like this, it's something IP and something like. First of all, change the host name, right? Change as master. Is it okay? This is as master, right? So if you want to change the name, just go to Google and type like this. Easy to change change host name or something. Easy to change host name, right? Type like this. Now just access this Amazon documentation pages. There you can see how to change the host name and all. You see here, this is the command to change the host name, guys. Sudo hostname ctl set hostname like this, right? Then copy and paste here. Go to your master server. This is the master server, guys. Here, copy and paste. What is the computer name, guys? Master, right? Let's say master or something. So, master server. Just say master server, right? Master. Enter here. What you can do is, just see the name is like this. See the name is like this, guys. Name won't change. What you can do is restart the server. Restart the server. Say init 6. Restart the server. Once the server restart, you can see the name master, right? Same goes to other servers as well. Log into other servers and change the name, right? Working on 1, working on 2, right? Say just copy and paste these things and change this as a work and order. Just these things copy and paste. Say work and not 1, right? Just enter. Then you restart the machine. The same goes to other work and not server as well. Let me connect this one. Otherwise, run the Terraform script. So in projects, we go for the Terraform script to change the name and all. Right. So this one is right. Say work and auto. Let me quickly restart this. Now everything fine, guys. Let me connect these machines quickly. First of all, let me connect master server. Right. Let's do master server. Now here you can see the name here, right? Let's see the name here. You can see the master here, right? Isn't it? The name got changed, guys. Okay. You see here, the name got changed, master. Right? Or you just type host name. You can see the master server, right? Let me connect this slave service or this worker nodes. You can see here, the name will change, guys. Worker node one, right? Host name, worker node one, right? Right. Let me connect other hosts, worker node two. Now we have master node, worker node two. You can see our host. This one is say this one is our worker node two. This one is our master node. We have the worker node two, and we have worker node one. Right? We have three servers. One is master and two worker nodes. Right? So first of all, we'll connect these servers first. First of all, we connect these servers. All the commands run on master node, guys. So whatever command run on master node, right? Right. So just follow this tube, right? First of all, install the Docker software. Right? So first of all, install Docker software. What is the command to install Docker software, guys? apt install Docker. Just put asterisk if you don't know the versions and all. Just put asterisk. Right? This is the command to install Docker. Right? Right? First, install Docker all three computers. Right? Okay, later. Okay, this one. Okay. Right. Anyway, okay. Go to master node, install Docker. Right. This is my master server. Right? Just put Docker. Okay. If you don't know the version, just put Docker. Right. The same command goes to other servers as well. Huh? Copy and paste. This. Building. Say docker.io also the important. Say Docker. By okay. First of all, update the servers. The servers still not updated, guys. Right? Okay. These are the fresh servers, freshly installed servers, right? First of all, update the servers. apt update, just put -1. Okay. So same goes to other servers as well. First of all, update the server since these are the fresh servers, right? Yes, update same goes to other servers as well quickly. Just copy and paste the command. Is the worker node 2, worker node 1, and the master. First of all, update the servers since these are the fresh servers, right? Now see, look here. Then install Docker. apt install Docker. Now it works. Other servers also install Docker, right? Go to other servers, worker node 1, apt install Docker, right? Just put -1. Then same thing you copy and paste to other servers as well. Go to worker node 2 and paste it. That's all. So here, guys, we have update the servers and install Docker. Okay? And install Docker. Now, first of all, let's create this architecture, guys. Let's create this architecture. This is master server. These are the worker node servers. First of all, run the token script in the master server. The master will generate a token. What you can do is you just copy and paste the token to worker node. That's all, guys. Then this worker node get connected with the master node. Okay. Right. So first of all, create a token. This is the command to create the token, guys. You see the command here. This is the command, right? Docker swarm init initialize. Okay. Advertise this. Right. You see IP address. Just paste this one. This is the command, guys. Say, let me put the command here. Let me put the command. So guys, say this would be -. Huh? Advertise, I am the master, right? That is the meaning. Advertise that I am the master. Advertise IP address. IP address should be the local IP address. Right? Okay. The master's local IP address. So this is the master server, right? This is the master server. Get the master server's local IP address. Just IF country. apt install net tools. Okay. Just install this tool, guys. Then only this command works, guys, right? First install this software, apt net tools. Just copy and paste it. Then type if config So it works, guys. So the command works. Okay. This is the master server's IP address. First of all, let me ping other servers. From the master server, let me ping other servers. Say, if you want to get other servers IP address, you can type ifconfig command or go here, go to the Amazon console. There you can find other servers private IP address. You can see other servers private IP address. This is the IP, guys. Just copy and paste. Copy here. Go to master and say and see whether it's reachable. Now we can reach worker-node 1. Okay, right. Let's go to worker-node 2 and copy the IP address and check the connectivity first, right? The connectivity is okay, guys. The thing is the security group is full open. Huh? Security group is full open. You see here, security is full open. Go to master node, click here. Security is full open. Huh? Full open. Right? So now the reachability is there, guys. We just check the connectivity. Okay, right. Now then run the command, guys. Run this command. Right? Docker swarm init this IP address. Let's get the master server IP address. Go to master server. This is the master server IP address, private IP address. Huh? Master server's private IP address. Just copy the IP address. Make the command like this, right? Then copy the command. Go to the master server. This is the master server, guys. Just paste the command here, right? Say it's a master server. Just paste the. Wait. Right. So this one creates the token, guys. Will create a token, right? Now enter here. Now see here. To add worker to this swarm, run the following command. Right? You just copy these things and run in our worker node. Then worker nodes join with the master. You see here there's a token number here. There's a token number here. You see here, Docker swarm join token. This is the token number. Huh? This is the token number. This one is the master server IP address. This is the port 2377. 2377. This port should open in the security group, guys. Okay. 2377 port should open in the security group. Okay. Right. So let me copy this the lengthy command. Copy the command here. Right. Right. Go to the worker node. Just paste the command here. Right. Just enter. Right. Just enter here. So it's saying Docker not found. Saying the command Docker not found, but can be installed with the thing is we install Docker, right? Isn't it? Okay. Anyway, what I can do is let me run this command. Docker.io, right? First install docker.io, then run the command, right? Say copy and paste these things, this software. Saying Docker, this software is missing, right? Enter. we installed already. Anyway. So now we install the docker.io software, right? So let's run the command and see whether we can connect with the master node. Now see, look here. This node join a swarm as a worker node. That means this one is connected with the master. Its role as worker node, guys. Its role as worker node, right? Say this node is ready, right? This node is ready, yeah. Right. Say let's copy the command to other node as well. Worker node 2. Just go to worker node 2. Just paste the command. So it's also complaining the software. Just copy and paste this. Just install docker.io is missing or something. Now see, just sorry, just run the command. Just run the command in the worker node 2 as well. Copy and paste here. Now saying this node join a swarm as a worker node. Worker, right? So guys, this structure is ready now. This structure is ready now. We have created this architecture. Now see guys, now look at, right? So what you can do is, just type the command like this, right? Say, look, go to the master. This is the master node, guys. Just read the last line. To add the manager to this swarm, run docker swarm join token manager and follow this. Okay, something like this, right? Say to add the manager to this swarm rule. Say if you want to add another master, run this command and add another master, right? This is for adding another master server, right? Another master server, right? Okay. Right. Now see, just type like this, docker service lessons. Give me a second. Docker node lessons. So if you type docker node ls, list down the node. Okay? List down the nodes. Right? Here you see the master server is there. You say manager leader is there. Others are worker nodes. You see here the active is there. Say active. Availability is active. There are different availabilities also. The active, you can pause it, you can drain it, blah blah things. You can see the Docker engine version here. The status is ready, guys. You can see here host name here. You can see the master, right? You see asterisk is there, master, and you see here IDs are there. Okay. There are some IDs for this Docker host. There are some IDs for this Docker host. Huh? We have IDs for containers, right? As well as we have IDs for the host as well, right? We can host also swarm come with ID, right? You can see host also swarm come with ID. This is the master node, guys. This is the master node, right? So this structure is ready now, ready to go, right? So inside this one, so it uses the overlay network, guys. It uses overlay network. Say here, look here. Docker network list. So it uses the overlay network. This one. Say Swarm. You see here, Swarm uses the overlay network. Right? The overlay network means, guys, say it's like this. Anything happen to the particular container, right? Or anything happen to the host, it will easily move this container to other hosts. Okay? Overlay network helps this container to move other hosts. Okay? We will see what is overlay network, right? You see here, we have studied bridge, we have studied host, we have studied none, we have studied. Other one is there, the overlay network, ingress, right? Here we have two bridges. That's what you see the two bridges here, right? We'll see what is overlay later, right? Right. So this architecture is ready, guys. Architecture. Let me create the containers, right? Let me create the containers inside this architecture, right? Look here. I am in the master node. You can run commands in a master node only. Go to master node, run commands. Right? So let me run the command like this, right? Docker service, guys, service. We have two services, guys, here. What are the services? Replica, global. Replica, global. Right. Let me use replica service now. Right. Now see, Docker service, create a replica. I would like to create two containers. Okay. Swarm will decide where to deploy the containers. Swarm will decide where to deploy the containers. Maybe here or here or here or here, here or here. Right? It will take the decision. Right? Just mention two. Right? Replica. Say, let me go for the port number. Just go port 80 or something, or 80 or 80, right? Port 80 or something. Say dash let me name, say a web 1 or something, web whatever name, right? Say let me go for Apache image, say Apache image. I don't think Apache image is there. Okay, let's go for Ubuntu image, right? Ubuntu image. I will, okay. I would like to go for Ubuntu image, guys. Say Docker service, replica service. I would like to go for two containers. These are the port number, name of the container, web1. So the same name goes to these two containers. Right? Say this is also web1 container, guys. Web1 container. This is also web1 container. The same name, guys. Same name. Web1. Right? Same name. Right? Say now enter here. flag Docker service. So the thing is, I would like to go for 2 containers. Say they should be plural, right? Replicas. Just put S, replicas. Okay. I would like to go for 2 containers. Now it's downloading the image and creating the container. Now it's saying, say, one is started. Or we'll use a different image. Yeah? So maybe the image may be some issue. So the image may be 1.2 or something. I'm not quite sure the version number. Ubuntu version. Okay, I think the issue is with the image. I think let me cancel this one. So just change the name, right? Because the web one already created us, right? That's the reason I just changed the name, right? Say, let me go for different image, right? HTTPD. Okay, let's go for this Apache image, right? So other the setting, other these things are seems to be okay, right? Docker service replica, to replica, right? Let me go for different image, right? Port already in use by it's already used. Say, right. So let me go for the different port. And anyway, at the moment, let me go for different port. Just leave it port, no need at the moment. Later we'll see the port. And thing is, it's already used by the. Give me a second. Right. Now I just deleted the container web one, right? Now I can use web one. The thing is, I have deleted. So go for the different name. Right? Now replicas, 2 replicas. The port number 8080 is okay. Name web one HTTP. Right? I can use this one, the same name. The reason is I have deleted the previous content. Right? I can use the same name, right? Enter. Now see, okay. Now is done. Now it's done, guys. Okay. Say service converge, then it is done. Now see here, Docker service LSNC. You can see this is the ID is there, right? The name web1, the two containers are running from this image. Port 80 is open, right? Exposed to outside. Docker service, guys. The replica service I had used. So, right, 2/2 replica. Now see, now type this command, right? Docker service, PS web1. Enter. Now see here. Okay. There are two containers. Say one is running on worker node 1. Other one is running on master. See? The same containers, guys. One is running on master node. Other one is running on the worker node, guys. You can see the status is running. Okay. You can see the status is running. So we have open port 80. Say 2/2, two replicas well placed in our servers. One is worker node 1, other one is master node. It uses latest Apache image. The name of these things is also this name. You can see the IDs. You can see the IDs. Okay. Now what? Okay. Now what I can do is get the master public IP address and paste. Okay. Let's see whether I can get the Apache test page. Go to the master server. Instance. Master server. Put the public IP address and paste here. It should work. So it's saying it works. Say, look here. Other one is running on a worker node 1. Go to worker node 1. Worker node 1, guys. Just copy the public IP address and see whether it works. So it says it works. Okay. Clear, guys? Clear? Say Docker service create. I have created two replicas exposed to this port outside, and the name of the container and this is the image name. Now see, I am running two containers, guys. There's a requirement to scale the containers, guys. Say sometimes if you receive high volume traffic, you have to increase your resources, guys, isn't it? If you experience high volume traffic, increase the number of containers. Scale in, scale out. Say if you experience low traffic, then scaling. High traffic, scale out. Now see here, Docker service. Docker service scale. scale. So this container, I would like to go for 6 containers first. I would like to go for 6 containers. Right now I have 2 containers. Scale out. So it's creating the 6 containers first. Preparing. Okay. Get the copy from the previous container and preparing and say the service converge. Now see Docker service ls and see ls. You see the 6 containers, guys. Now see here. Now type this command Docker service psl. Sorry, ps web1. So here, so we are running 6 containers. 6 containers. You see some are running worker node 1, some are running worker node 2, some are running master node. It's the running state, guys. This here, running state. And there's a requirement to scaling, guys. Okay. There's a requirement to reduce the container just to 2. Now we'll delete other containers, right? So now see Docker PS web. Now you see here. Now we have 2 containers. Again, we back to normal, guys. The running. Yeah, there's a question. Right. There's a good question here, right? Now see, now we are running like this. Say if we update this container, guys, what will happen to this container, right? Let's see. Right. Now see, let me modify the web page. Now look here. Say Docker. Say which one is running on master node? Docker PS, say master node, Docker PS and C. So this is the container. This container, guys, is running on master node. Let's modify some parameters or just change the website or whatever it is. So what I can do is Docker attach. Just go to just copy the container ID. Oh, you can use name as well, right? Enter. Just go to the container now. Can you go to the container? Wait. So guys, can I access the container, guys? Okay. So here we can manage the containers. Here we can manage the containers. When I go inside the container, it's not possible. Say you cannot attach to stop the container, start it, stop and start, right? That is okay, right? So why is like this? Say the programmer will create the code. He will create the code, guys, and ask you to create the Docker file. We will see the Docker file next class, not today, right? Then from the Docker file, we are creating the images, guys. From the Docker file, we are creating the images. These images, if you want, you can upload to the Docker hub or whatever it is. From the hub, you can download the images. Right? So if you want to modify these things, what you can do is, first of all, just ask the developer to modify some parameters. Right? Once he modify the parameters, or he come with the whatever changes, then we create the Docker image or upload or just put it to the Swarm, right? Then we can run. So say here, I just try to access this one, guys. I try to access this container. You see here, say Docker attach these things. I cannot access. Right? So all these containers are same containers, guys. All these containers are same containers. Right? All are same containers, guys. Right? Right. So if you want to go for update and all, then what you can do is first you get these containers as image and get the backup. Right? Then to run then you get the new image from the developer and run the control. Here we manage the containers. Can we go inside the container? Can we go inside the container? Can't. So whatever here, guys, whatever software here, same software here as well. Same software here as well. All these containers are come with same software. Right? Here we can create the container, we can delete the container, right? We can scale the container, scale in, scale out, right? Blah blah things. Can we access these containers? No, we can access. Right? So we manage the containers. Okay. But if you go for Kubernetes, there's a way to access the container. Right? We'll see in the Kubernetes. Right? So it comes with some advanced features than Docker Swarm. Right? Very advanced. Right? Right. So that is the question from Lasita. This option will replicate it all updated data. Yes, right? It will replicate, right? But here we can access. So that's what we are getting the same page here. Say it works. That's what we are getting same page. This one is from master node. This one is from worker node. Same containers. That means same containers. Is that your question, Lasita here, right? Lasita, are you okay? Okay. Right. Clear? Right. Now see here, we are here, right? So we are here, guys. Right? Now we have done some tasks here. Right? So guys, shall we go for a short break or shall we continue? Right? So guys, what we can do is we'll go for the short break now. Now the time is 7:40. We'll go for 15 minutes break, guys. We'll start around 7:55, right? Okay. Okay, then we'll go for the short break. Huh? So guys, let's start. Let's start. So guys, just notice the command, right? Just notice the command. Let me put some commands here. Huh? Let me put some commands. Say, look here, guys. Say. So when we start Docker, we just type like this. Say. So we just type the command like this. Say Docker run or some. Docker run interactive, right? And blah blah things. Here we just type like this. Docker service. See, all the commands start the Docker service. Which service? Swarm. We are using Swarm, guys. Swarm service. Swarm management service. That's what it's starting like this. Docker service. Docker service scale. Docker service PS. Right? Right. Now see here. Now see here. Docker service LSLC. Okay, list out. So I am okay. Now see. So now we have learned these ones, right? We have learned one service, replica service. Now let's see what is global service. So if you use global service, that means it will create the content all these Docker host, right? We will create the content all these Docker hosts. Here one, here one, here one. Right? Then why we use this service, global service? The thing is, if you want to monitor the particular software or particular container or particular host, we need the agent all our Docker host, guys. Right? All our Docker host. Right? Now let's see how this global service works, right? So it's global, guys. Just say what you can do is, give me 1 second. You have to change the mode, right? Now here, remove replica. This time, I would like to go for the global service. Global service. Then say, say just a mode as, let's type mode here, mode as the global. And let me go for the web 2. Right? So let me go for web 2. Right? Web 1 already there, guys. Web 1 already there, right? Say let me go for web 2, right? Now enter and see. Port 80 also, or port 80 already used. Okay. Say let me use a different port. Web 3. Yeah? Okay. Now see. Docker service ls. You see the mode has changed now. The global is a web 3, right? 3/3. This one is in all container. Sorry, all Docker hosts. Right? All these containers are in all Docker hosts. Right? Now you type like this. Say web 3. So you see here, this one is container, the same container created in all hosts, master, worker node 1, worker node 2. It has been created all these hosts, see the wording. See these containers created all these hosts, right? That is the global mode, right? So you can see the mode here. The mode has earlier is duplicated. Now it's global. Right. Say first we type this command, right, isn't it? Say docker node, list down the node. Yeah. Say use here. Say we have one master node, the worker node. Right? Say type like this, you can get the help, guys. Right? Say if you don't know the full command, you can get help. Just type like this. You can see here. Say docker node, you can type ls, you can type ps, rn, remove one or more nodes from the swarm. Right? Update the node, demode the node, demode one or more node from the master in the swarm. Inspect ls, list node in the swarm. If you want to list the nodes, just type like this. Docker node, then type ls. We will discuss what is demode, what is promote. We can remove the node as well, believe me. So demode, what is demode? Say right now this is the master node, guys. This is the master node. Very important. See, master node. Now you can demode. That means this has a worker node, this has a master node. That means you can promote this worker node as master node. You can demode this master node as worker node. Demode. You can promote this one, you can demode, right? Then this one will be the, if you promote this as a master node, then This one will be the master node. This one will be the master node. You can demote this one. Then this one will be the worker node. Okay, promote, demote. Right? We'll discuss that one, right? Now see, say Docker, just type Docker node, just type Docker service dash help, just type it. Simola, sorry, Docker service dash help. You can type the help as well. You can see the help page. Create, say we just type Docker service create, Docker service inspect, log, Docker service ls, ps. Right? Then see here. Let me type like this, Docker service. I know the next keyword is create. This is the next keyword. Then you type like this, help. Let's get the balance command, right? Enter. You can see the balance command. Still, you see here. Say Docker service create, and these are some options. The image, okay, command, the argument. So anything come with this one, guys. Anything come with this bracket. This bracket. So these are the optional part. Linux or any of the Linux flavor. These are the optional part. But anything come with these brackets, you must use. Okay? Whatever come inside, you have to use. Okay. You must use the parameters. Anything come with this one, optional. You can use or not, as you wish, right? Right? Say Docker service create. Okay. Say some options. The image should be there. And the command. Okay. Now see, let me copy these things. First, let me copy these things. Now see here, just enter. Let me get one create command. Say Docker service create options. Options are start from dash guys. Dash. See? You see them? Say options are start from dash. You can see what are the options, right? Options. You have to use the image. Is must image HTTPD. The minus name also one option. You can use many options, one option or many options, okay? Right? And some argument as well, say minus p as a argument. Okay? So you can see here options. These are the options, guys. Say guys, this also option, the minus p also option, minus p also option, right? You can add the port, not argument option, p also option, right? Option. You see the options. Say create replica is the option. Say you see here the replica. Say replicas, the plural. Replicas unit. Number of tasks. Okay. Replicas 1 unit or 2 unit or 3 unit or whatever number replicas. Right? You can set the CPU limitation, memory limitation, blah blah things. Say a networking parameters. We can mount points. We can give the name, service name, dash name. Say we can give the name. We can give the replicas, okay, the ports, and the image. Right? Right? This is how you can use these commands. Right? If you don't know, just type help. Docker service create, just type help. Say Docker service rm dash help. RM mean remove. Docker service RM and the service. You can remove it. You can use RM or remove, both works. Say Docker service, we are using Swarm service, Docker service, PS, let's say web one. Here we get the, we'll see what is these things and all. Right? Now look here, say Docker node ls. Now say Docker node just take help. You can demo, say Docker node demo, Docker node inspect ls promoter. Now let's discuss about the demote and promote. Right? Now let's see. I would like to promote this worker node as a master node. This one, promote as master node. If we promote, then here we can run commands. We are running commands in master node, guys. Okay. If you want to run commands, the node or the host should be master, isn't it? It should be master. Here we can run commands, guys. See, look here. Let me copy the same command and paste it one of the worker node. This is the worker node 1. You just type this command. Type this. Docker node lsnc. Error response from daemon. This node is not a swarm manager. See, you say this node is a worker node. It's not a swarm manager. Worker node can't be used to view or modify cluster state. Please run this command on manager node or promote the current node to a manager node. Right? So worker nodes, we can't run commands, guys. Master node, we can. Master nodes, we can run commands, right? Now, let's promote this as master node, right? Let's promote this as a master node, right? So just what we can do is, give me a sec. What is the keyword we use, guys? What's the keyword? Promote. Promote, just type help and see the balance command. Docker node promote, and you just give the node name. Node name, huh? Yes. Say what is the node name? Or you just type a node. Or what we can do is just copy and paste it. Worker node 1, right? Work this one. Now we are promoting, guys. Say node, worker node 1 promoted to a manager in the swap. If he has been promoted as manager now, this is the manager now. Say just type like this. Docker node LSNC, SLSNC. Now see, the reachable. Reachable means it's a manager. If you get like this, reachable is the manager. Now let's go to the worker node 1 and run some commands. And go here and run some commands here. It works. That means it's a master. It's reachable. So it's saying reachable means it's a master right now. Now we have two master servers, guys. We have two master servers. If you don't like, then you can demo, right? Say you could go here. Say what is the command here? A demo. A demo. And now we demoted as well. Now let's run the command lsnc, not ls. Now see again, is back to the worker node, guys. That is known as, guys, demote, the promote, right? LS means list node in the swap. You can list down all the nodes, all the hosts, right? PS list stars running on the one or more nodes. Right? Right? The process say PS say web, right? Task say process say sorry. Okay. Docker service, right? Docker service. Should be known, no? Should be known. Docker node, the PS is there. If you don't know the balance command, just type help for some help, right? PS options. This task running on one or more nodes. Now, say let's copy the host name, right? The worker node one. You can see these tasks are running in this worker node. Docker node PS is these tasks are running in this worker node. Running, right? Say if you want to check with the other one, sorry, node 2, you see here. So these tasks are running on worker node 2. Right? Okay. We can list down the task from master node. We can list down the task which is running on here, which is running on here, blah blah things, right? Okay. Now see. Now we will see something different. Now see. Now there are some containers running. Now if I delete this one, say if I delete this Docker host guys, what will happen? So these containers moves to other Docker host guys. if you delete this Docker hosts, will move to other containers, will migrate to other containers. Right? Now look here. Now look here. Say type like this, Docker node is something connected with the node. We are going to delete the node, guys. We are going to delete the node, the host. Docker node. Just say update. Docker node update help availability blah blah things, right? Now Docker node update. You see here options, availability, active. The pause means stop the node. We can drain. We can delete the node. We can delete the node. Right? So if you delete the node, right, it will move to other the containers moves to other hosts. Right? Now see. Where can we see the active, guys? Where can we see the active? Now see. Docker service PSNC. Wait, Docker service LS. Now see active. Availability is active. Availability is active. So if you say drain, you can shut down. If you change as if you can, you update the availability as drain, right? You can update, right? You can update. Right? Now see here. Docker node update. Second, availability is there, right? Docker node update. Then dash availability. Just copy and paste. Okay. Dash help. Enter. Docker node update options node. Okay, right? Just put availability. Then say drain. Right? Drain. Right? Say drain. Just mention the node name. Right? Option mention. Okay. Say let me shut down this one. Okay. Let me shut down work node. If there's any maintenance purpose, we shut down some nodes, right? We shut down some hosts, right? So just drain this one. Just shut down it. Right? Enter. Now see. Now all the containers which are here, it moves to other host. You see here. Okay, let's see. Now see here, this node is shut down. Say whatever node here, these nodes are migrated. See, this node migrated somewhere here. This one is shut down. See, still we have 3 nodes. Sorry guys, wait. So wait. Give me 1 second. So we have shut down see why is saying master is shut down. Worker node is running, okay. Master is running. Worker node 1 shut down. But this command say web 2. So this one is shut down, okay. So we are running master and the worker node. Two of them are running right now. That is okay. So web 1. Web 1. Say worker node is running. Worker node 1 is shut down. Master is running. How come this one? Okay, wait. Now see, Docker node ls says the drain state. The worker node 1 is in the drain state, drain state, shutdown. So both these are active, right? So this one is okay, but say web 3. Okay. See, look here. See, web 1.1 earlier runs on worker node 1. Now see, right now is running on worker node 2. Right? master node, but this statement need to check, right? Anyway, I'll check the issue, guys. Right? Saying we will down the master node, right? But this one is correct. See web 1.1 is runs on worker node 1 early. Now it's running on worker node 2. Say web 1.1. But this one need to check, this statement need to check, guys. Right? Anyway, I'll check the issue, right? This one. Says ran here, is now is running here. This ran here is running here. So let's check with web 3. Because there's no these things. So global mode, anyway, the error is there because it's running on global mode, right? Right. So anyway, I'll check these things, guys, right? And there's some bit confusion here. Right. Anyway, I'll just check these things. Huh? Right. Okay. So if you shut down something, so these things move to other these things, other hosts, right? So meantime, we can pause also. Say meantime, we can pause these things also, right? Say is active is there, pause, we can try, right? Pause also possible, right? So if you pause something, say if say just pause this one, okay? This one is in the pause stage, okay? Pause. Pause. Now see, so we pause this host, right? Then we are deleting this one. We are deleting this one. Delete this host. So this container won't come here. This container won't come here. Thing is pause, stop. It also will be deleted. This container also will be deleted, guys. So here we pause this one. Then we are deleting this host. Then this container also will be deleted. It try to move here. The state is paused, then it won't move. It also get deleted, guys. Right? So that's the thing. Right. So we have 3 options here: active option, the pause option, otherwise a train option. Right. These things, don't worry, I'll check the issue. What's wrong? So we have shut down the worker node, but it's saying master also shut down. Right? So that's it. Anyway, I'll check these things. Huh? Right. So guys, this is something about Docker Swarm. Right? Docker Swarm. So people would like to go for Kubernetes, guys, because it has more advanced features than this one, Docker Swarm. Right? It has more advanced features, guys. Right? Right? So that's what the development team would like to go for Kubernetes. So before start Kubernetes, guys, there's another small part is there, Docker file. Right? We will see how the Docker file works. Right? We will see how the Docker file works. Now see, say, look here. These are the images. So we are downloading the images, guys. We are downloading the images in our computer. So we are downloading the images, guys. We are pulling the images. We use the command known as docker pull Ubuntu, docker pull MySQL. Likewise, we are downloading the images, guys. Right, images. From the images, guys, we are creating the containers, guys, right? From the images, we are creating the container. Right? From the Docker file, guys, we can create the images, guys. From the Docker file, we can create the Docker images. Right? From the images, we are creating the containers. Now look here, the developer is creating a software, guys. The developer is creating the software. Right? Say once a developer created, he hand over to you guys. Once he created, he hand over the software to you. So we are going to write the Docker file. We are going to write the, say, a Docker file, guys. We are writing the Docker file. Then we convert this Docker file as images. Right? Then we convert to this as containers. The Docker file is a root. Is a root, guys. From the Docker file, images, containers comes. Right? So these things come from, all these things come from Docker files. Right? All these things come from Docker file. Right? Now we will see what is Docker file and all. Right? Say Docker file, guys, we have there. We are going to use some commands inside Docker file, guys. We are going to use some commands, guys. Commands and all. Right? So, guys, from the Docker file, we can create the images. Right? Now see guys, say it's the Docker file. Say we can use the command known as a copy command. Say we can use run command. We can use cmd command. We can use give me 1 second, guys. Let me check the commands and all. Add command, right? So we can use entry point command, entry point, right? We can use user command, we can use expose command, likewise guys, we can use some commands, right? Okay. Using these commands guys, we can create an image, Docker image. Docker image guys, using these commands. The developer gives to the Java development coding. He developed the coding and he gives the Java code. So we use these commands to create the Docker image guys. So this code converted to the image. Don't bother about the coding part guys. The coding part belongs to the developer or the development team. Right? They will take care the coding part, the Java, Spring Boot or whatever, blah blah things, right? Don't worry about the coding part guys. They will do. Okay. Concentrate on these things guys. Right? So what we can do is, so we need more time for the Docker file. So we can complete today. So what we can do is we will make this one to next time, right? Next class, right? Before that, we will sort out this issue. This issue comes here. We'll sort out this issue. Don't worry, right? We'll do it. Then we will move to a Docker file. Right? Once we complete Docker file, then we move to Kubernetes. Right? So this one is bit lengthy part, right? Docker file bit lengthy part. Anyway, we need at least two classes, right? For these things. So we complete this one. Then we move to Kubernetes. Right? So guys, any questions? So guys, if you don't have any questions today, then we will wind up the session today. Then we will meet next class. Okay then guys, goodbye and good night.
Good night, sir.